In the real world, solar panels have to endure constant temperature swings, morning to evening, shade to sun, dew to frost. And temperature variations are tough on solar panels because their electrical connections are metal. When the temperature rises and falls day after day, year after year, different expansion and contraction rates in that metal can cause those connections to break. The problem? Broken connections can't conduct energy, so the panel loses power. True, there are industry standard certifications, but they're not designed to guarantee a lifetime of performance against real-world conditions. Sunpower is dedicated to ensuring that its panels perform well over 25 years and keep working, hassle-free for every one of them. So at the Sunpower Labs, scientists test for temperature changes at 13 times the industry standard. This is the temperature cycling chamber, designed to simulate real-world temperature changes for over 2.5 decades. Inside, solar panels are subjected to rapidly changing temperatures. First, the temperature falls to -40 degrees Fahrenheit. Then it rises to 185 degrees Fahrenheit, all in under 5 hours, and then it cycles again, and again, and again. How does a conventional front contact solar panel fare in these conditions? Not well. In fact, as soon as the test begins to exceed minimal industry standards, leading front contact panels start to fail. But under the same test conditions, Sunpower continues to deliver. Why? Sunpower's unique patented Maxion cell technology uses thick plated copper contacts with built-in strain relief. They're robust and flexible, so they can handle the expansion and contraction that comes with temperature variation. Conventional panels, on the other hand, use thin and narrow baked-on front contacts, and with no strain relief, the electrical connections can break. Sunpower, designed for life in the real world. In the real world, solar panels have to stand up to moisture and humidity, rain, snow, fog, wet summer heat, again and again, year after year. And humidity can be a big problem because when moisture penetrates solar panels, it corrodes the internal metal components of the panels. It can also react with the silicon in the cells, further reducing power output. True, there are industry standard certifications, but they're not designed to guarantee a lifetime of performance against real-world conditions. Sunpower is dedicated to ensuring that its panels perform well over 25 years and keep working, hassle-free for every one of them. So at the Sunpower Labs, scientists test panels for moisture and humidity changes at 3 times the industry standard. This is a damp heat oven designed to simulate real-world humidity for over 2.5 decades. Inside, panels are subjected to 85% humidity at 185 degrees Fahrenheit. How does a conventional front contact solar panel fare in these conditions? Not well. In fact, as soon as the test begins to exceed minimal industry standards, leading front contact panels start to fail. But under the same test conditions, Sunpower continues to deliver. Why? Cell design is key. Conventional cells use thin baked-on metal for the electrical connections. In humid conditions, the thin metal corrodes and breaks electrical connections, resulting in power loss. Sunpower, on the other hand, uses its patented Maxion cell technology, a unique design with thick plated copper. It's extremely robust and withstands corrosion to deliver consistent power. Sunpower, designed for life in the real world. In the real world, solar panels have to deal with heavy loads, wind, hail, snow. Even shipping and installation stresses can cause cells in the panel to crack. What's the problem with cracked cells? In conventional panels, damaged cells essentially stop working, reducing the panel's power output. They can also cause the panel to heat up and accelerate aging. Sunpower is dedicated to ensuring that its panels perform well over 25 years and keep working hassle-free for every one of them. So at the Sunpower Labs, scientists subject Sunpower's panels to a range of intense loads to make sure that they can survive a lifetime of physical stress. This is the dynamic load test, uniquely designed by Sunpower to mimic real-world loads. Sure, it may not look like much, but this panel is enduring pressure equivalent to 90-mile-per-hour winds, applied over and over. That's 880 pounds of weight applied again and again. What happens to a Sunpower panel under so much stress? Very little. The conventional panel, on the other hand, shows significant damage, resulting in power loss. Why such a difference? Cell design is key. Conventional front contact cells have a thin layer of metal baked onto the silicon crystal, which offers very limited strength. Under pressure, the cells shatter, causing a precipitous loss of power. But Sunpower's patented Maxion cell technology has thick, plated copper covering the back of the cell, providing structural strength and allowing even a cracked cell to continue producing power. Sunpower, designed for life in the real world. In the real world, solar panels regularly undergo partial shading, sticks, leaves, dust, even bird droppings. And what happens when a solar panel is partially shaded? That depends on which solar panel. For some, a shaded cell can lead to significant power loss. Why? Because a shaded solar cell can't generate power, and it can't properly pass the power generated by its unshaded neighbor cells. Instead, it dissipates that power, resulting in additional power loss for the entire panel. For this conventional panel, partial shading on just one cell shuts down a third of the entire panel. But Sunpower is designed differently. Sunpower's patented Maxion cell technology is optimized with built-in protection, so that if and when a leaf, or anything else, shades a cell, only the shaded cell powers down, resulting in far less power loss. Let's look at the power output of two panels under shading in this experiment. Sunpower panels are more efficient than conventional panels to begin with, so they produce more power. Now let's see what happens when we shade a small portion of the panel. Sunpower is operating at 89%, while the conventional panel is down to 66%. And if shading continues over time, a conventional front contact panel will fail, resulting in 100% power loss. But Sunpower's Maxion technology has built-in protection for each cell, ensuring consistent power production even if shading continues. Bottom line, Sunpower panels are designed for the real world, and Sunpower's exhaustive testing ensures that their systems perform consistently, hassle-free, for well over 25 years. Sunpower, designed for life in the real world.